Let's proceed to the fourth part of the course, Virtual Lens Selection with ESA. Virtual fitting significantly simplifies the practitioner's workflow, making it considerably more efficient. This can be undertaken using either of these two platforms, ESAFit and SimuLens. Both platforms use 3D positioning of the ESA lens from a large virtual trial set of 10,395 back surfaces contained in the platform database. The program performs several hundred virtual fittings and then selects the best one to achieve optimal tear film thickness and central clearance. In addition, the platforms contain a calculator that allows you to accurately determine the impact of the selected lens. It is important to remember that corneal topography must be performed accurately, complying with several conditions that we will discuss below. Otherwise, the likelihood of virtual fitting errors increases. The corneal center, which the program aligns with the center of the lens, can be determined using various methods. For Medmont E300 and Meridia topographers, which provide a corneal photograph with Placido ring projections and a known pixel to millimeter ratio, a specialized module has been developed. This module identifies the ellipse that most accurately matches the shape of the cornea's transparent zone. This ellipse defines the horizontal and vertical diameters, and its center serves as the geometric center of the cornea for all program calculations. In our experience, this is the most accurate option for achieving a precise fit. Regardless of the method used to determine the corneal center, it is unfortunately impossible to calculate the correct lens diameter with sufficient accuracy using topography. Consequently, physical trial lenses must be fitted for this purpose. The calculated center position may vary slightly across different topography captures. Therefore, to ensure maximum accuracy, it is best practice to take 4 topographies and simulate 4 corresponding virtual fittings. From these, you can analyze the results and select the optimal lens to order. Later, we will explain the specific steps for this process. To ensure that virtual fitting based on corneal topography is as accurate as possible, 3 essential conditions must be met. 1. Accurate determination of lens diameter. 2. High-quality topography. And 3. 4 topographies and corresponding virtual fits for each eye. We already discussed diameter evaluation in parts 2 and 3. The quality of the virtual fit is directly proportional to the quality of the topography. Never rush this stage of the process. To ensure the highest accuracy, follow these 5 clinical requirements. 1. The topographer is correctly calibrated. 2. The topography is taken in semi-darkness. 3. The patient's head is correctly positioned on the chin rest. 4. The patient's eyes opened as wide as possible. Eyelids should be held back if necessary to reveal the entire corneal surface and limbal area. 5. The topography capture is taken within 3 to 5 seconds of blinking. Once we have established the correct diameter for each eye using physical trial lenses and captured 4 high-quality topographies, we can proceed with the virtual fit. The patient does not need to be present for this stage. Each topography for each eye must be exported as an individual file to be successfully imported into the ESAFit or SimuLens platforms. When logging into ESAFit, you will be prompted to enter your organization, email or username, and password. The topography loading window will then open. From the drop-down list, select the topographer model you are using, for example, the Medmont E300. Next, navigate to and select the desired topography data, 1 topography capture of 1 eye. Depending on your specific topographer, this may be an individual exported file or an entire data folder. The drop-down list of topographers can be adjusted in Settings. Here you can select the specific device you use in your practice. If the corneal photograph and the ellipse construction module are available, the ellipse construction window will automatically open. You must ensure that all technical requirements are met. Specifically, the image should clearly show the limbus and the adjacent sclera across all 4 sectors: superior temporal, superior nasal, inferior temporal. In this topography, the eyelid has cut off a significant portion of sector 2, and sector 3 is almost entirely absent. As a result, approximately 40% of the corneal perimeter is not measurable, rendering this capture unsuitable for an accurate virtual fit. In this topography, sector 1 is largely inaccessible for measurement due to eyelid obstruction, while sector 4 is compromised by significant reflections from an excess of tears. This topography is acceptable. All sectors are clear and well defined. Using your cursor, left-click to place red points along the corneal periphery, ensuring at least 4 points per sector. Increasing the number of points will improve the calculation's accuracy. Aim to place these points precisely at the transition between the transparent cornea and the limbus. Distribute them evenly, ensuring that some are placed as close to the sector boundaries as possible, provided there is no interference from the eyelids or lashes. After placing your manual coordinates, press the Calculate button. The program will then generate its own optimized points based on your selections. These will appear as green points, which the software will use for the subsequent calculations. You may find that some of the points generated are clearly misplaced. If there is a significant discrepancy, click the Clear button and repeat the process of placing red points, correcting the locations where the initial measurement was inaccurate. If the discrepancy is minimal, it may be neglected. In certain scenarios, you can use the right mouse button to force the placement of measurement points, which will appear as green immediately. However, it is best practice to use this feature sparingly. Click the Accept button. The platform will then calculate the recommended lens and display its parameters. Note that when determining the initial lens diameter, the software prioritizes the smaller corneal diameter, which is almost always along the vertical meridian. You can manually adjust these parameters, including the total diameter, nominal K, and toricity. However, it is strongly advised not to change the nominal K or toricity selected by the program. In cases where the corneal photograph and ellipse construction module are unavailable, the topographer will automatically determine the corneal diameter and geometric center. You can manually adjust the corneal diameter with the dialog box if your clinical measurements differ. ESA then utilizes this data to perform the virtual fitting, calculating the recommended lens and displaying the final design parameters. As previously noted, the software does not always determine the corneal diameter with sufficient accuracy. Therefore, it is essential to establish the correct diameter beforehand using a physical fitting lens. Enter this measurement into the designated field. If your clinical measurement matches the software's recommendation, no further adjustment is necessary. If you have manually adjusted the diameter, click the Auto-Fit button to trigger a recalculation of the virtual lens. In some cases, the nominal K and/or toricity may change following this. Calculate the target power using the platform. Enter the spherical component of the patient's myopia or hyperopia into the SPH power field. It's important not to use the spherical equivalent. The software accepts both points and commas as decimal separators. Ensure you include the minus sign for myopic prescriptions. In the vertex distance field, enter the distance in millimeters. If you determine the subjective refraction using a trial frame or phoropter, this value would typically be 12 millimeters. If the refraction was performed with a trial spectacle lens without a frame, then it would be 8 millimeters. Click the Calculate button. All necessary lens parameters are now set. To save the virtual fitting, click the Save Fitting button. The lens parameters are stored in your browser's local storage and will remain accessible until the browser cache is cleared. Each subsequent lens you select will also be saved, building a cumulative list of your designs. Please be warned that if you delete cookies and site data when clearing your browser history, all your saved lens designs will be permanently erased. As previously established, you must obtain 4 high-quality topographies for each eye and generate 4 corresponding virtual fits. When comparing these results, the following scenario may occur. 1. 4 lenses with identical nominal K and toricity values. This is the ideal outcome. 2. 3 lenses with identical nominal K and toricity values, and one showing different values. The lens that repeats 3 times should be selected. 3. 2 lenses with identical nominal K and toricity values, while the third and fourth lenses are different from the first 2 and from each other. In this case, the lens that repeats, the matching pair, must be selected as the final one. 4. 2 matching pairs of lenses. You should select the pair with the lower nominal K value in diopters, which corresponds to a higher value in millimeters. 5. 4 lenses with differing nominal K and toricity values. This is an extremely unlikely situation in clinical practice and almost certainly indicates that the topographies are of poor quality. You should delete these fittings and retake the topographies. The target power calculated by the virtual platform may vary slightly across your 4 virtual fits. However, this parameter is not particularly critical to the clinical outcome. When selecting from lenses with identical nominal K and toricity, you should choose the one with the highest power value, unless your clinical judgment suggests otherwise. Click the Create Order button to open the table containing your saved fittings. For each eye, select the correct lens, as determined through the previous process. If necessary, you can manually adjust the target power at this stage. Once the correct lenses are confirmed, delete any redundant designs by clicking the red cross icon on the right. Finally, enter a unique patient identifier, such as a medical record number, to ensure accurate record keeping and prevent future errors. By clicking the Download File button, you can export your saved lens fittings into an Excel spreadsheet. We strongly recommend downloading your data daily to prevent accidental loss due to browser cache clearing. By default, ESA Fit automatically includes the current date in the file name to help you maintain an organized chronological archive. To place an order with the manufacturer, you can email the generated Excel table directly from the platform. First, click the Create Order button to review your list. Verify that all the necessary data is present and accurate, and that all redundant or outlier lenses have been deleted. If you need to order a lens with predetermined parameters, click the Add Manually button. This allows you to bypass the virtual fitting process and input each parameter individually by selecting the appropriate values from the drop-down lists. Click the Send Order button to proceed. In the recipient field, enter the manufacturer's email address. You can type this manually or select a saved contact from the drop-down list of previously used addresses. Once the order has been placed, the lenses are automatically cleared from the order table. If you want to delete all saved lenses from the table, you can do so by clicking the Clear All Data button. Because this action is permanent, the platform will display a warning message. If the lens diameter you specify is larger than the patient's minimal corneal diameter, the platform will trigger an error message. If the platform displays the message "No lens fits" after a virtual fitting attempt, it indicates that the corneal parameters do not allow for an adequate fit. The SimuLens platform features a very similar interface and logic to the ESA Fit system, so the clinical workflow remains the same.